Yeah, so I'd like to talk about what I kind of titled DevOps for the Rubyist soul, which is kind of how we come from being in love with Ruby to figuring out how we could use it for DevOps stuff. The first thing I want to point out, this is my first time in Texas, and it's so my first time in Dallas, and I was in New York last week for another conference, and I live in Chicago. Everybody here is way nicer than I'm used to. Yeah. So I've been good so far, and so like Jim, I'm also going to talk about Ruby outside the web, which is kind of why I had my hand up, because most of the Ruby I do does not generate any kind of HTML. Anybody read Ruby Parlay? Yeah, a couple people. So Josh Susser always recommends kind of opening with some audience participation or something. So here's my attempt at some audience participation. If you like recognize what this is and you think you understand what it is and you've seen it before, raise your hand. All right, now keep your hand up if you verified the fingerprint before typing in yes. All right. So now you can go and figure out if that was a joke or if I was just figuring out who to target later. So as I was introduced, I'm John Downey. I'm an infrastructure engineer at Braintree. Braintree is a payment service, so we help other companies accept credit card payments online. And if you're in the audience and you use Braintree, I'd love to talk to you after this and get whatever feedback you have, because we're always looking to talk to our customers. So as far as Braintree goes, I wanted to kind of give a backstory so we can so I can talk about why DevOps, how it happened. And so every startup has their business plan. Usually they're better than this, but we kind of help with that phase 3, how you actually make the profit. And the way we do it is with banking integrations primarily. You should be very happy that you never have to directly talk to a bank. So it's not just like you're talking to a computer system from the 70s. You are talking to a computer system from the 70s. And it's pretty interesting. The other thing we do is secure credit card storage. This really helps our merchants not have to deal with compliance burden, but it then places more of the burden on us. So security is a really big part of what we do at Braintree. And then one of the last things is developer support. So we really kind of pride ourselves on how we feel we support our developers, and with the white glove phone support and everything that we provide. We also try to do really good documentation, and we're always looking for feedback on it if you have any for us. But now kind of to the crux of why I was telling you this. So at Braintree, we are other people's infrastructure. So if that kind of makes sense, we have to be very highly available. If we go down, that means not only are we losing money by proxy, but our customers losing money. And typically people get really upset when that happens. So we try to do, we try very hard to have no downtime. And that includes both planned and unplanned maintenance. So, not to knock Twitter, they're kind of in a different class of scale and a different business than we were, but we could never really get by with a fail whale type thing. So that brings us to DevOps. So for those of you who aren't familiar with what DevOps is, the goal is to kind of bring the rigor of agile development to the complexity of managing servers and server operations. And the way we kind of do it is with these 3 things. We want it to be automated, repeatable, and verifiable. So you can kind of think that's very similar to how agile programmers think about testing and things like that. We also want, because dev and ops are so highly linked, it's really a symbiotic relationship. And the role, there's certainly so much overlap that it's worth having a combined role. That way we don't sort of point fingers at one another. So I want to tell a couple stories, and they sort of interleave. And the first one is how Braintree got to DevOps. So at Braintree, we love Git, and we try to use Git for pretty much everything. And we also love Ruby. We have a lot of different backgrounds in programming language specialties. Before I worked at Braintree, I was a .NET developer. I kind of describe it as the Venn diagram of our developers is we all intersect at kind of a love for Ruby. And that will kind of help frame the decisions that we made later. like you probably are, we use an agile process. In fact, we used to have a physical card wall, believe it or not, before we, now we have multiple physical locations, so that's a little out of the question. We try to pair on almost everything, at least everything that at least everything that makes sense, and we definitely pair on all production work. And it's just great to have another set of eyes and another set of hands, especially if you mess something up, that they're right there to help you out. So the reason I'm telling you about this is I want to tell you about how we notated our cards for a while on our card wall. So back in the beginning, we would place stickers on the physical cards. Red was kind of pickup work, kind of like a cookie jar, if you will. Green was new projects or features. Yellow was maintenance. And blue, well, blue was for infrastructure. So as the team grew and the task grew, sub-teams began to form around these specific colors. Like that's kind of how things organically would grow, you would think. So a small band of misfits formed the blue team. And this happened right around the time I joined, so I kind of somehow got put into this. And we like to call it guerrilla DevOps. So we weren't planning on being DevOps engineers. It just sort of happened. And we did it from the trenches, and we tried to figure it all out together. The second part of the story I want to tell is my path to DevOps. So I really love Linux. And I don't just like Linux, I like Linux. If I went to high school with Linux, I would have passed it this note in class. Tried to nervously ask it to prom. So when I got to Braintree, we were trying to figure out like which team should I join and which team would need me. And I got put on the blue team. I would imagine because of my like for Linux. I didn't quite know what that meant at first. So I had played, I managed servers, but I'd never done it in like an automated or repeatable way. I'd never used server configuration tools, but I all of a sudden became a DevOps engineer. Fortunately, though, I had a great set of people to pair with that helped me figure this all out. Also, for fans of the movies, I do know that these scenes are out of order. I apologize. So by becoming a DevOps engineer, I had to learn a new set of tools and a new vocabulary. So cap, QA, puppet, noop is almost like a capus, nupus patronum or whatever. And I'll explain exactly what that means in a little bit. So at Braintree, the first tool I'd like to talk about that we use is Puppet. Puppet really helps out when you want to manage your servers, and you use it to write a program that kind of pulls the strings at the servers, to use the Puppet analogy some more. Like all the tools I'm going to talk about, it is a Ruby. It is implemented in Ruby. You can get it as a Ruby gem. The language, however, that you program in is not Ruby. It's its own language, just to make things a little bit more confusing, called Puppet. But we'll go over a little bit of what that means. Most Puppet configurations run in this way called Puppet master. What that means is there's a central server that runs like a master node, and then all the nodes are run these things called agents, and they connect to this master node, and that's where they get their marching orders from. And they try to stay in lockstep with the server. The reason I bring this up is because it is the typical way to do it, but it's also not the way we chose to do it. So we'll get in a little bit more about why that is later. So I want to do a quick introduction to Puppet, and we're going to break down this example. So just like Jem, I don't expect you to read all this at once. I want to break it each part down. So Puppet files are called manifests, and they typically live in a folder called manifests, and they have this extension .pp. So when Puppet boots, it's idiomatic to start with the manifest site pp. That's kind of how it bootstraps itself. In Puppet, you have these things called nodes, and this is how you tell a server how to configure itself. And the way we call this out is with the host name of the node. One of the things we're doing here in this example is we're installing Ruby using the OS package manager. So in Debian or Ubuntu, it's just apt-get install Ruby. This runs the exact same thing. And it ensures it's installed. So if it's missing, it'll install it. If it's there, it will just this is a no op, or just cleanly moves over it. The next thing we're doing is we're declaring a variable. And later we'll see a better way to do this, but I just want to show that you can do this in line. And we'll see where it kind of pops out on the other end later. You can also tell Puppet, I want to manage specific files. So if this file isn't there, Puppet's going to do its best to make sure it shows up. We're saying the content is coming from this herb template, which is really cool because we're Rubyist, remember. And it's going to have this owner group mode, etc. So this is just a made-up herb template for that example, and you can see, herb should be familiar to all Rubyists, especially if you're doing some kind of Rails. I imagine you recognize what's up here. Notice we're using this blah variable that we defined. It kind of has shown up in our configuration for us to use, and we're also using a Ruby iterator, so we have the full Ruby chainsaw here to use. But it was kind of weird that I just decided to install that package in line with the node. Like that certainly can't scale. So Puppet also lets us extract things into classes. Here we've taken this Ruby package install and moved it out to a class. Notice that we've named the class Ruby, and it's in a file called ruby.pp. That's important because that's how Puppet is going to link the two. And then later on, we can go back to our example, and we can include Ruby. So I don't know if this makes the same connection as it did the first time I saw this, but this means that we have abstractions. And as programmers, we love abstractions, because that means we can build some really interesting things with this. This will let us go and then kind of build up these generic manifests that we can share across all of our different nodes. Another thing Puppet comes with is something called factor. This is yet another Ruby gem, and its purpose is to gather facts about what is happening on a system and expose that to Puppet. So here we install the gem factor, and I just ran this on my laptop, and we get spit out all these different things that's going on. My hardware is i386. I'm using a Darwin kernel, as you can probably see. And one thing that's interesting is, you can see hostname. So that's the hostname on my laptop, and that's how we would figure out what node to run. Puppet pulls the hostname fact and then uses that to figure out the node. We can also use these facts to kind of branch in our manifest. So if we wanted a specific branch for Ubuntu and a specific branch for CentOS, we could use the operating system fact to do that for us. Another kind of thing that Puppet introduces is the way they expect you to organize your code is in modules. You can kind of think of a module like a Ruby gem, and it has its own set of ways that things are expected to be organized. So this is a typical layout for a module in Puppet. We recognize some of the things up there already as Puppet manifests, and we also have our herb template again. But we have a new thing hanging out, just something I decided to call SumFile. This is a file that is just going to be put out by Puppet, and it's not going to be interpolated by Ruby at all. It's just a raw file. The entry point for your modules is called init.pp. You can kind of think of it as the initializer or constructor. And then by idiom, we're going to put all files managed by this module in files, all packages that it's going to maybe want to install in packages. And this would be a good place to maybe use a fact to determine what package to install based on our operating system. And then what services we want to define would go in this services pp. This may be like initd, god, upstart, depending on what you're using. So modules are this way that we want to kind of organize our Puppet code that we use to configure the server, but they are kind of a gigantic mess if you just have to write all of them yourself. So I realize now that it's actually a little bit easier to see up there than it is on my laptop, but there's something called Puppet Forge. The Puppet community has come together and they decided, I don't need to everybody write their own Nginx module. We'll write one good Nginx module and put it up there and have everybody use that. Also, like the Ruby community, no one can exactly agree on what it means to be a good Nginx module, so there are about 4 or 5. But it's a great place to check for these generic things like MySQL and things that you just probably don't need to write yourself. So Hira is another part of Puppet by default now, and Hira is kind of the newest part, and I think is the most important. Hira lets you manage the configuration of your servers in a hierarchical format. And that's just a bunch of buzzwords, but I'll hopefully be able to explain what that means. YAML is the format I'm going to show. YAML is what we use at Braintree. This is a sample from our infrastructure repo repository that we have, and kind of an example of our Hira setup. This is for our, you can kind of see the tree for, we have a Chicago data center, and by that we mean it's the rack in the back of our office. So this part of the Chicago data center we'll go deeper into. There's a common YAML, so every server is going to pick up this file, thus it's common. But inside the Chicago data center, any server name that begins with DB is going to pick up this file. But any server that begins with DB01, which presumably is DB01 or maybe DB011 if we were ever so inclined, though I don't think that would be a very confusing notation, will pick up this. So DB01 will pick up these three configuration files, and they override each other in a hierarchical way. Now, the DB01 isn't actually that interesting, so I decided what I wanted to show you was Zen02. Who's familiar with Zen? Show of hands. All right, so for those of you who aren't familiar with Zen, Zen is a virtualization platform. If you are running a Mac, you probably know it like Parallels or VMware, Fusion, or VirtualBox. Zen is a way of doing that on servers. EC2, for example, uses Zen, so it's battle-hardened. We use Zen to run all of our virtual machines, and here is kind of a snippet of how we have these nodes set up. This is just YAML, and it just shows up as a variable inside Puppet. So instead of having these things inlined, we're going to have them all out in a central place. Another thing that we can do with Hira is we can interpolate other Puppet variables in it. So there's no, and these things can be generated on the fly, so there's no need for us to have this duplication all over the place. We can kind of build up our configuration pragmatically. So now this kind of brings me to sort of a central thesis about Puppet, and I totally stole this from a colleague, so I will give him credit for that. Puppet does not manage truth. Puppet maps truth to complexity. Yeah. So we used to have, and we still do, we're making it better, we used to have truth strewn all throughout our Puppet configuration. Little variables here and there, branches here and there that would decide what happened on a box, and you would spend hours digging through and trying to figure out what exactly happened. The goal is to move all of that to Hira, and then use these variables that Hira exposes to do things, to make the changes later. So Puppet is taking the truth, which is Hira, and mapping it to your complex system. The way I like to think about this is let you build up a Puppet model of what your system should be ideally, and then also it's hierarchical, so you can kind of extend and overwrite things as you will. So once again, when I figured this out and it was explained to me, kind of blew my mind at first. But now I think it makes total sense. So that's Puppet, and that would be a pretty general overview for anybody who wants to use Puppet. Now I want to talk about what kind of we do uniquely at Braintree. We decided that for a lot of reasons that I'll go over a few, we wanted to run Puppet in masterless mode, so we didn't want to use Puppet Master. Instead, we decided to, and we wrote a utility called supply drop. This lets us run Puppet on individual nodes without having them singly coordinated, and we do that using a lot of rsync and capistrano. So the gem name is supply drop. As you can probably imagine, you can find it on GitHub. It's also in Ruby gems. And this is kind of the secret sauce of our infrastructure and how we manage our servers. So for a simple example, we're going to make just a new infrastructure folder. We're going to install supply drop. Supply drop is going to bring in capistrano with it because it's a dependency. We're going to capify. I guess I should forward my slide. Install supply drop. We're going to capify. So we're going to make this a capistrano controlled folder. And then we're going to modify our cap file. So who's familiar with capistrano? All right, that's why, yeah, so a lot. It's pretty ubiquitous. Instead of some vanilla capistrano where we deploy Ruby, probably a Rails application, we're instead going to use capistrano to orchestrate all of our servers. At Braintree, we orchestrate hundreds of servers in this manner, and it's been working out pretty well for us so far, and that's across multiple physical data centers as well as cloud providers. The underlying it all is this little macro. Ours is more complex than this, but it simplifies down to something like this. And we install supply drop. This will hook into capistrano for us. In our data center tasks, this macro will define two things. It'll define a data center level task for us so we can touch every server in the data center. And it will also install this server task so that we can be very precise as to which server we want to talk about. We then use it, as you could probably imagine from the parameters, to set up the environment and then every server in the data center. For our purposes, we're going to use this real simple Puppet manifest that just installs Ruby. You'll notice I named it puppet.pp, even though the idiom is use site.pp. We only found out about that later, and supply drop was written to default to puppet.pp, so it's still in there. So once we have that and have that all set up, we're going to try to run a cap command against our server. And the command we're going to run is puppet noop. So we pronounce it noop. I imagine you would normally pronounce it no-op, but that's just kind of the terminology that's grown up around this. And this will go out and try apply against the server where the changes aren't actually written. It then lists and tells you everything it would have done if you were applying instead of nooping. Always read the diff. So this is probably like item number one. We always read the diff because this is going to change our server. In QA, maybe it doesn't matter as much, but in production, it certainly does. Once we're happy with the diff, we can apply. This will actually run Puppet on the local box. The first thing it does is rsyncs Puppet, or the Puppet configuration up, and then it shells out using capistrano to run the Puppet command locally. Once things are applied and you didn't break anything, we go ahead and we noop the entire infrastructure. Oftentimes you may not realize that by changing this one piece over here, you may have changed a box on the other side of the infrastructure that you didn't think about, which often happens when these things grow up organically like ours did. So this, once you've figured out that you're clean, it's time to use Git. So Git is the other kind of part of the secret sauce that we use to do masterless Puppet. Normally I would write a better commit message, but it had to fit on the slide. And we just want to say what we did and add it and push. So now that we have supply drop kind of hooked into capistrano, what are some of the things we can do with it? The first thing we can do is target a specific node, like we saw already. Using the power of bash expansions, we can also target many nodes at once. And so this will actually noop app 0 through 12 in once. It'll rsync it out and just do it all as one block. And then we can also run an entire environment. And because capistrano already comes with its own like Swiss Army knife of tools, we can use things like cap invoke to just run the ls command on every single box in an environment. This is really good for PS if you want to know what processes are running on every box in a pinch. So I mentioned we use Git to kind of control this. We have a setup where we have a Git branch per environment. Master is maps to QA. The other ones map to what they kind of, the obvious name for it. And this lets us do things like we can take our configuration and merge it between these branches. So we can build something and sort of let it bake in QA, merge it up to staging, let it bake there a little bit more, and then finally take it to production. And we can do this in a very controlled manner. So when we want to move up, we just check out and merge. and then we nuke the entire environment. This lets us see what kind of baggage we brought with us in this nuke. The other things you could do, which we often do, is use the git chainsaw to do this. So, look at the diff between the two branches, look at the log messages between them. Oftentimes we try not to, but we do occasionally cherry pick between the branches if it's going to be a hairy merge. Once we're good with it, we can apply. Normally, we would not apply the entire environment at once. That could be kind of dangerous. You would never, obviously, apply in production all at once. But this is just an example of something you could do. And once you've kind of applied the merge, you push. And that's your way of making sure that everybody is on the same page as you. So, like I mentioned earlier, we love Git. And so Git plus supply drop lets us do sort of this decentralized guerrilla DevOps. We can let each pair or sometimes solo member of the blue team work on different parts of the infrastructure, sometimes different environments, usually different servers. For example, I could be working on a Nagios check, and another person on the team could be working on tuning some Postgres configs or something, and we wouldn't have an issue. Later, we can merge, and we'll have the same results across the board. This process of merging we call going up and down the infrastructure. We try to do it often because it can be quite hairy if you delay in doing it. The way we notate this and the way we talk about it is production is up and QA is down. This keeps us from having to ever say production and down in the same sentence, because if someone just overhears that in the audience, or in the room, they tend to get really nervous if you say, especially if you're on the infrastructure team and you say production and down. So this leg of the journey from staging to production is, I think I'm the only one that calls it the danger zone, but I really like to call it the danger zone. So when you're in this leg, you always make sure you have another pair of eyes with you and another person watching the terminal, even if they're not driving. That way, if something bad happens, they can break off and help you fight the fires immediately. And whenever we're doing this, we always have a plan. We always know exactly which servers we're going to apply to, because we need to maybe unbalance them first so that we don't affect any of our customers. So with Puppet Master, we've kind of gone off the beaten trail a little bit. And in just the way we developed Puppet internally, we learned a lot of lessons, sometimes the hard way. So I'm going to go over each of these in a little bit closer detail. The Puppet style guide was something we didn't start reading until much later than we should have. There's a reason you want to write idiomatic code, and that's because the conversation around it is usually a lot easier to grok. Without the idioms, you tend to apply your own, and if everybody sort of has their own, then you maybe won't make sense of what's going on. It also helps your Puppet repository stay clean, because they've been doing this and they know what pitfalls also to look for. So use modules. When I came to Braintree, the blue team, we had an infrastructure repository that was made up of approximately 0 modules. It was all manifests, and it was all very hairy. And over the last year or so, we've been teasing these things out into modules so that we can retain our sanity at the very least. The reason why you want to use modules is modules let you compose things. There are generic components. Hopefully you're getting these from Puppet Forge, but these represent basic services like Apache or Nginx. And then there are your services that are unique to what you do. For one of the Braintree example is we have a Braintree app server or a Braintree proxy server. And these things are made up of various components, and we've composed them into something that makes sense for us. The next thing that I'll highly recommend is Puppet has a facility for backing up files. They will keep every version of a file that you've changed on the system over time, and you can go back and retain them. So even if you Puppet apply, if you're using Puppet backup, you can go get that file. This, however, does suck for large files. So if you're pushing out a big binary blob that lets you talk to a backend processor over a VPN connection, which we have, you need to turn it off. Otherwise, you're going to be versioning, like every time you change this 800 meg file. The last one is merge regularly, which we've kind of covered already. It's the same reason we talk about in Agile to deploy often. The less you merge and the less you deploy often, the more difficult it's going to be when it comes time to actually do it. So we try not to let changes linger, certainly longer than a week. We try to go up and down the infrastructure once a week if possible. So the last tool I want to talk about is Vagrant. I really hope everybody here knows about Vagrant already. If not, prepare for another mind-blowing part. So Vagrant helps you automatically build out VirtualBox machines. As you can imagine, just like everything else I've talked about, you can gem install Vagrant. They do, however, not recommend you do this method anymore. Since they're 1.0, they have like an official package that you can install. And what Vagrant lets you do is, in your current folder, you run Vagrant init with a base image that you want to build off of. For example here, I'm using Precise, which is the latest LTS release of Ubuntu, and I want the 64-bit version. So that will just write out a Vagrant file for me to use. I then run Vagrant up. That's going to actually download the box, if it's not already cached locally, spin up the VirtualBox machine that I need, and configure it. I can then SSH directly into it right from there. So with these 3 commands, I can get a VirtualBox machine with a plain version of Linux installed up and running. So the Vagrant file is just Ruby. You can configure it using the same things that you would normally do. Here, this is the init. This is where it stuck what base image we're going to use. I then define 2 servers, and so by default, you're just going to get one called default. Here, I'm defining 2 servers, a web server and a DB server. And this lets me bring up 2 servers at once and has some port forwarding. So I can bring up a mini environment and start getting things talking to each other in an interesting way. The next thing that is really cool about Vagrant is you can provision it with Puppet. So if you know Puppet already and are using it, you can then point it at one of your Puppet manifests and have it start bootstrapping the node when it comes up. This is like really handy for the next 2 things I'm going to talk about. Using Vagrant to rapid prototype. So a lot of the really cool technologies we use these days are clustered and distributed. So to do that, you typically want to try it out on more than one node to get the real feel for it. Vagrant lets you really quickly set up a multi-node environment on your local box. You don't need to do it on EC2 and pay the 10 cents or whatever. You can just do it locally and see how things interact. So for example, we were testing out RabbitMQ about 9-10 months ago, and we spun up 3 or 4 Vagrants locally and used that to test the high availability failover between different Rabbit nodes. And we ultimately decided that Rabbit was something we wanted to invest more time in because we did this prototyping. The next thing is development, more specifically a development box. Over the last couple months, we've decided that instead of running our builds and everything on our local laptops when we want to develop, we're going to use this development box, which is just Vagrant, and we use Puppet to provision it. This lets us move things off of OS X, where we don't deploy, and onto Linux, which is much similar to what we do deploy on, and it is exactly what we deploy on. It also lets us not run things on your local box like Postgres and Elasticsearch, which you just probably don't want 90% of the time running on your Mac, only when you're developing. It also makes it really easy to get new developers up and running. So instead of them spending days reading a wiki of every homebrew command that they need to install, and finding numerous errors, and then our answer is inevitably, well, it's a wiki. Edit it and fix it. Instead, we can give them this development box. It puppets itself, and then we can just get them up and running, and they can run the builds and usually have everything passing that day. So that was the last of what I wanted to talk about, and I wanted to leave you with a little bit of DevOps humor. So if you're not familiar with it, this is DevOps Reactions is a Tumblr, and it's just animated GIFs, like most Tumblrs, of some funny things. So this is specifically funny for people in DevOps. The title of this one is How Stoneth Works. So for those of you who don't know what stoneth is, don't feel bad. Stoneth stands for shoot the other node in the head. It's a ops term. It's an ops facility where you're using clustered services. The only way to guarantee that you know what state the cluster is in is to literally rip the cord out of the wall of the other box. So if you get your cluster into a bad state, the one that determines that it's going to be master pulls the cord on the other one so that it knows it's master. So this GIF animates that. The next one is DevOps Borat. If you're interested in DevOps, I highly recommend that you follow DevOps Borat. Similarly, DevOps or Big Data Borat if you're interested in big data. So these are Borat tweets of some things that may be humorous to you if you're interested in DevOps. So that was all I had. My name is John Downey. I work at Braintree, and you can check me out on Twitter. Thanks.